all. Okay. We are doing today's POTT. Okay, maximize happiness of selected children. You're given an array happiness of length n. Okay, happiness array and a positive integer k. There are n children standing in a queue where the ith child has happiness value happiness I. You want to okay happiness array, every child represent the happiness value. Okay, ith value, it's a queue. Okay, you want to select k children from these n children in k turns. Okay, k turns में select करना है. Okay, that's fine. Is it from the start or end? Maybe in each turn when you select a child, the happiness value of all the children that have not been selected will now decrease by 1. Okay, I can select any random child. Note that the happiness value cannot become negative and gets decrement only if it is positive. Okay, if the happiness value is greater than 0, it will decrease. If it is not selected, return the maximum sum of happiness values of selected children you can achieve by selecting k children. So okay, that's fine. Okay, this is the example 1. We are given happiness array and k2. We need to select 2 children out of 3. 1, 2 and 3 are the happiness value. Okay, explanation, we got an output of 4. How we got it? The explanation is we can pick 2 children in the following way. Pick the child with the happiness value 3. The happiness value of the remaining children becomes decreased by 1. 1 will decrease to 0 and 2 will be 1. Pick the children with the happiness value 1. Okay, the happiness value of the remaining child becomes 0. Note that the happiness value cannot become less than 0. Yeah. Now the sum of happiness is 4. Happiness came. Okay, for the second output, let's see third output. We are given 4 children, we need to select 1. Okay, we only select 5. Okay, and for that happiness second example, we need to select 2 children, however, and the happiness value of all the children are 1. Okay, I can get exactly 1 and I cannot get more than that because all the values left except 1, all the values are 1, and after selecting a single child, the other child should be 0 decrease because it is decreased by 1. Yeah, let's see the constraints. Okay, length can be up to 10 to the power 5 unit, tens, 100,000, 10,000, 1 lakh elements, and 10 to the power 8, 1 crore, 1 crore, 1 cr values, and k can be greater than 1. It will be at least 1 and will be less than equal to the number of children. Fine. Now thinking of sorting it and selecting always the maximum above maximum child and maximum happiness child so that it won't decrease it. No. So the value I'm getting will be the largest. So I'm always picking the largest child, and does it matter which child I select? Should I select the minimum child? Should I select from the cage from the sorted happiness list? Should I? And I will just I will just look at the k window, size of window of k from the end. So max 1, max 2, max k minus 1 elements, k elements. Should I pick the starting element or can I pick the end element? Like I need to explain this. Okay, this is the happiness array. Happiness A1, A2, A3, A4, A5. This is go, and first I will sort karo, and let the max 1, max 2 I will get it starting. Assume that it is sorted in decreasing order. Okay, to a max 3, okay, to n kind of, no, n elements. So Okay, I will only look at I can only select k values, k children. So I will pick the first k children's. Should I pick the smallest first or largest first? Should I pick max 1 or max 3 or a k minus 1 children? Uh, okay, if it's something, if it's x, this is y, this is less than y. Hence, all the children will decrease by 1. All the children will decrease by 1. Okay. Okay, fx. If I just select y, then I am getting y plus then x minus 1. Or if I select x, then I will get y minus 1. In the end, it doesn't matter, kind of. Let's see for 3 children's. Let me select this, shift it up. Let me select this also and move it up a bit. Okay, if I have 3 children, x1, x2, x3, then if I select x1, then this will decrease by 1. Now I select x2 minus 1. If then x3 will decrease 1 more, so x3 minus 2. This will be x1 plus x2 plus 3 x3 minus 3. And if the order I change it, if first I select x3, then x1 will decrease by 1 and x2 will decrease by 1, so I got x3. If I select x2, x1 will decrease by 1 more, this will be 2, and then at last I will pick the 2, so this will be 3. The equation doesn't change, so I can pick the children and decrease by 1. Next children will be decreased by 1, next other child will be yeah, I got it. I think I got it. Let's test our hypothesis. Okay, we first sort the arrays dot sort HLP NESS happiness, and int result will be getting the return res. Oh yeah, return the res. HAPPINESS. Okay, now for int I equal to HAPPI. Okay, we will make another variable with size and equal to size of array. Length I is equal to n minus 1 to 5 and I greater than 0 and minus I. Okay, bounding condition, when I will know that I picked. Okay, and greater, and the bounding condition is n minus I. Okay, n minus I is can be greater than equal to k. Yep, take care. And what are the subtraction? What should I minus? What should I minus? The minus will be for the element will be the size of window, current window size. Yeah, that will be for the nth element n minus I minus 1. Okay, yeah, this will find like for the n minus 1 the element n minus 1 plus 1. Okay, I, so this will be plus 1, right? n plus 1 and plus 1, and should I subtract minus 1 to make it 0? So I am subtracting 0 from it. For the second element I will be adding 2 here and subtracting 1, so in the end I will subtract 1. Yeah, that's fine. That should be if current element HAPPINS this current element minus the what is the minus, okay, min, and int subtract equal to n minus I minus 1, that will be n sub, is greater than 0, equal to 0, we will break it. Is less than equal to 0, we break out of the loop. We have selected k children's. All the children doesn't matter, they will be at least 0, they cannot be negative. So now result plus equal to plus equal to p pi minus sub, I think. If any typo if there, let me check for code. That's good. And variables n minus I greater than equal to 1. Yep. Minus I, yeah, that's good. I think it should work fine. Oh yeah, damn, we did it wrong. Redis dot sort, we are at n minus 1, we're decreasing. N minus window 1 greater than equal to 1, yeah. Plus 1. 1 is less. Okay, less than equal to. Okay, we are checking at the window size, right? This should work. Yeah, this is working. Submit it. 10 to power 8, we can use counting sort also, think. Oh shit. Oh yeah, let me check the oh yeah, the sum can be long. Long. Let me submit it. Shit, I think yeah, integer and long don't go well with together. Oh shit. Okay, let's submit again. Yeah, okay, we have done the today POD. It was way similar, very easy today. No, let me done. Let me screenshot. Let me capture the coin perfectly. I like to collect this. I don't know if no one does, but I do. Very much crazy. Okay, done. Saved photos. 152. We had one wrong answer and one compilation. That was due to my own mistake. It's nlog n, fairly nlog n. Log n, yeah. Let's see the, oh yeah, shit. Again, I submit it. I beat 43 in the previous, okay, in the current 43% and the previous 70, same code. Leetcode should sort plus greedy. Yeah, that's the approach. And nlog n was the heap priority and greedy. That's still nlog n. Yeah, that's fine. Nlog n plus k log n still nlog n. Okay, we have done it in an optimal way. Now, okay, let's end this. My aim was to solve this on stream. Let me show you my count. Leetcode count. We are done 820 questions. 1, 2, 3, 4 4 months of consistency maintained. Yeah, 556 mediums, 80% daily challenges. Yep, think I'm doing great. I need to tackle more hard and more hard mediums. Okay, that's it for today. I will come tomorrow and